Hey, this is my week 5 homework. So starting out, this first thing, uh, so this program right here, lines 1 to 32, I'll, this program will store my stocks in the number of shares that I own, and it will get the latest prices from them. It should calculate the value of each stock position, and it will add it up to get the total portfolio value and print the results. So starting out with line 4, we are creating a list for stocks and quantities, uh, or for lines 4 and 5, we're creating a list of stocks and quantities. Then line 9, this code's going to fetch the latest prices from Yahoo Finance. However, Yahoo Finance wasn't working, so I had to go to the Alpha Vantage, to be able to get that information. Um, And then, so that's the need for lines 10 and 11. We're sending a request to Alpha Vantage to fetch stock data. And so that's the purpose of this response and request. And moving on to line 18. Here we're just getting the price for all the stocks, and the purpose of this is to loop through all of our list of stocks and the prices. And then line 21. We want to multiply the stock quantities by prices to be able to get the total value per stock. So if the price is, if the price is, sorry, if the price is not there, it would just give us none if the price is not there, if it cannot be found. Or if the price is none, then it would just replace it with a 0 to avoid a crash. And so that is the purpose of this line. And then line 20 or 38 or 28 and 32, it's going to print out our results by looping through each stock, and it'll print the quantity, the price, the total value, then the total portfolio value. So let's check, see if that will run. And right here for 10 shares of Apple at the current price 24. Sorry. Save that. At the current price of 10 shares, or at 10 shares at the current price 24.48, 22.44.87, it will give us this return. Same for Tesla, and same for Microsoft, and it will give us our total portfolio value right here. And then next, this here it's gonna. So the importance of this is that we're requesting. The request will fetch stock info from Alpha Vantage. The pandas will process the stock info into a data frame, and then Matpilot is going to plot the stock prices with um, buy and sell points. And then 42, right here, we're building the URL with the Alpha Vantage, or the URL API, and so to be able to do that, we are having to use the symbol and the API key right here and the URL to be able to get a response to it, and it was just sending a request. And then lines 46, this right here, it's extracting all the closing stock prices, and it will convert the data into a pandas data frame, and we have an except key error to give us something so that our code will still run if there's an error here. And lines 58, starting out, this will create a copy of a price date of the price date or data, sorry, copy of the price data, and it's computing the 5-day simple moving average, right here. Uh, and so we get that from the rolling window 5. And then the same for the 20-day simple moving average. This is from the rolling window 20. And then line 64, this function will find buy and sell signals. So um, it'll mark the buy when the 5-day simple moving average is above the 20-day simple moving average, and when the 5-day is uh, less than or equal to the 20-day simple moving average. And it's also the same for the sell. It'll be the 5-day when it'll sell when the 5-day is below the 20-day simple moving average, and it'll give us this return of here. The next, so this function is plotting the chart. It plots the price chart with the buy and sell signals on the chart, and there will be a line to show the stock price. So this is the purpose of this. This line will be showing the stock price in black, and I'll show you here in a second the chart that we get. And then the 5-day simple moving average will be, the line style will be dashed, and it will be blue. And on the chart there will also be a 20-day simple moving average. It will be labeled as a 20-day, same as the 5-day, and then it will also be dashed, but with color of red. And then down here, lines 77, or sorry, but yes, this is all part of the plot. Line 77, we're having our buy and sell signals with the marker of an up arrow or down arrow. And right here, these are also just more of the kind of the key for it, that it will explain what's going on. And this right here, at the end, it will give us our symbol, and it will fetch the stock prices for us. And here we're computing the averages, and still also find the buy and sell points. And all of this is that if there is no price, it will just split, it would shoot out none at the end. But this is for the plot chart that we have, that I'll show you here in a second. But we ran the code, and these are the dates. These are its closing prices, the 5 days moving average and the 20 days moving average. So if the 5 days ever greater or below, we'd buy, but we never get any of that here. And then same for here. And so this is where we'll get our chart of the stock price, which is the black line, the blue line, which is 5-day, and the red, and then our buy and sell signals. And then our next one, lines 99 through 123, we are creating a simple bond calculator. And this is a list that contains the names right here, of bond A, bond B, and bond C. It contains the name, the face value, the coupon rate, and the years to maturity, and the market price. Here, those are the years to maturity, coupon rate, market price. And then also right here we have the formulas to be able to get the estimated yield to maturity. We're defining the function right here to be able to calculate the yield to maturity, and we set the coupon rate from this formula. We get the coupon rate from this formula, the yield to maturity, and round it to 4 decimals, which is the point of this right here. Line 113, we're looping through all of the bonds to be able to calculate the yield to maturity, and so that is the purpose for this 4, because it's looping through all the bonds we have in our list. And then 117, we're printing out the bond name and the yield to maturity that will run in our terminal, which is right here. We get our bond name and the yield to maturity based off all these calculations from before, or based off the formulas from before, and the inputs from here. And then 122, we're finding the best bond with the highest yield to maturity, and it'll print out the result. And so it gives us, it says that bond B is the best bond with a 6.70% yield to maturity. Next, this is lines 126 through 148. And so on this one, the purpose is that we're creating an array of data prices, an array of daily prices, and we're calculating the returns and finding the highest and lowest prices in their positions. And so we're using a number, numpy, and so at 128, we're creating a numpy array of the daily prices. It will store daily prices, and we're using the numpy because it can also be better for just math operations. It's better than list, so that's the purpose of using it. And so here we have a list, or the array of all our data prices here. And then next, our daily returns. We're calculating the daily, the monthly, and the weekly returns. And so this NP difference, we'll find the difference between each day's price and the previous days before, while dividing its price by -1. And so this will convert it into a decimal, or not a decimal, sorry, a percentage. And the same for the weekly return, but 7 for 7 days, and then the monthly return, the last price versus the first price, which is 0. And then next, 137. So this NP max will find the highest price. The NP minimum will find the lowest price. The NP arg max will find the position of the highest price, and the NP arg minimum finds the lowest price. So that is the purpose of these, because it's coming back all the way from this table, or the array of daily prices. Sorry. And then here we're just printing out the results from the daily returns, the weekly returns, the monthly returns. So this is rounding 4 decimals. This will be rounding 2, and this will be which one of the highest and the lowest of the day. So let's go down to price analysis. So we have our daily returns right here. Our weekly return is 16.50%. Monthly return is 20%. With the highest price on day 10, which is 120, and our highest price on day 1, which is 100. And it's stemming back all the way from these. And then next, 155 to 177. Here, we're creating another numpy array. The assets here will store different names of the asset classes, and so that is the purpose of this line. So we have stocks, bonds, real estate, and cash. Those are the different asset classes and their allocations. Right here, the current allocation will store the current percentage allocation of the portfolio. So 6%, 25%, 10%, 5%. These are the desired percentages. Or sorry, wrong one. 50%, 30%, 10%, 10%. Then here is our desired. It's our target allocation, which will just store the desired target, desired percentage of allocation. Sorry. And here we're getting the difference between the target allocation minus the current allocation, and that's how we were able to calculate the differences. 165. That was 165. And if it's positive, we will buy more, and if it's negative, we will sell. Here, 168 and 169. So we're saying that the total portfolio value will be 100,000, which is the purpose of this, and the rebalance amount. Um, so this is converting the difference into a percentage change into a dollar amount using this formula. And then moving down, here we'll print our results. This right here, oh, I'm sorry, asset allocation rebalancing, which is you can see right there. But for this four, so the 4i in range will loop through all of our asset rebalance amounts, and it determines whether to buy or sell based on the sign of the rebalance amount. And then we're using the rebalance amount to just show positive numbers. This ABS rebalance amount is to show the positive numbers. And so down here, we ran the code, and we were able to get the asset allocation. So we are 50% in stocks, 30% in bonds, 10% in real estate, and 10% in cash. Our target is 60%, 25%, 10%, and 5%. And then we make up the differences right here, and this is how we're going to rebalance it. And so next, our last one is 181 to 198. And then here we're creating a risk calculator. So we start off with the numpy arrays, and we're creating two numpy arrays, one for stock returns and then one for bond returns for 10 periods. So 1, 2, 3, 4, 5, 8, 9, 10. 10 for both. And these are the returns that we're getting on these assets. These are the historical returns, I should say. And then here correlation, so this tells us that a positive one will move together and a negative one will move opposite of each other. And so this is the purpose of these numpy coef between the stock returns and bond returns. And next 191, so the weights, we set it up to 60% stocks right here, and then 40% bonds. The cove matrix, so this computes the covariance matrix between the two of the stock returns and bond returns. And this numpy square root, this is using the matrix multiplication to calculate the total risk. And this is the standard deviation of it all. And here we're printing out the results, this risk analysis, the correlation between stocks and bonds, and then the portfolio utility, which we get from these two. And for ours, our correlation was between stocks and bonds was 0.91. So next it was the portfolio volatility, and it was 1.14.